Hi, everybody. Josh Byerly here inside Mission Control Houston. I'm joined by Rose Flores, who is the Orion Crew and Service Module Chief Engineer. Let's talk about Orion for a little bit. We've got
Sure.
EFT-1, which is Exploration Flight Test number 1, coming up next year in 2014. A big day right now because the heat shield just arrived at the Kennedy Space Center last night and is being unpacked today, right?
It is. It certainly is. It came in from Boston
Yeah.
and flew on the Guppy and landed yesterday evening.
So how exciting is it to actually see real hardware? We're seeing it getting packed right here, I guess, before. That's a big box. That is a big heat shield. Talk about the size of it a little bit.
It is a very large heat shield. You know, we've spent a lot of time developing it and testing it and transporting it. Really, the Guppy kind of made sense because it's as large as it is.
Let's talk about we talk about it's the biggest one ever built, right? Now, why is it, well, first of all, why does it have to be so big? And second of all, why do we have to do so much testing? We're seeing the actual engineering process of building it here now, but, people look back and go, okay, you did heat shields back in Apollo. Why does it take so much to build a new one? Like, talk about the technology that goes into it.
Well, so for the crew and service module, this one is a lot larger than our Apollo capsule. So that drives the size of the heat shield. For EFT-1 specifically, this particular heat shield is designed for the mission that we're doing.
Mm-hmm.
So for later missions, it'll, the size of the heat shield will change, at least the ablative surface will. But the technology itself, we actually ended up using the same manufacturer for the AVCoat material as we did for the Apollo. For the Apollo vehicle.
So is it closer to the Apollo, kind of, without getting too technical, sort of the Apollo composition versus what the space shuttle, the space shuttle had those famous tiles on the bottom, so it's more...
It is more Apollo-like. The structure
it's ablative,
itself,
right?
yes, it's ablative. So the structure itself, the structure is a metallic structure with a composite laminate over it, and then we've got the honeycomb that you can kind of see a little bit in the video that you're playing right now.
Yeah, you can see it.
You see a little diamond honeycomb, and we actually place the AVCoat inside that honeycomb surface. So that is essentially what burns off as we re-enter, whereas the structure itself, it's titanium. It's a titanium skeleton with a composite laminate structure over it.
Yeah.
And then we've got the honeycomb and filled in with the ablative material.
So let's talk about EFT-1. The purpose is to basically send this out several thousand miles out into space, and then bring it back in at a speed and velocity that sort of mimics what you would see at either a lunar return or one from deep space, right? There's sort of the mock-up of what it would look like.
Right, so it's a high altitude re-entry profile that we're running. So it's a high energy re-entry profile, and essentially we're trying to get at some of the heat rates and heat loads that we would have for a high energy entry.
Because it is different coming back.
It is different coming back
from,
that's right, it's a different approach, and what we're expecting to see on this flight is, try to capture data that's going to help us evaluate and design the next heat shield that we use for each additional mission.
Yeah.
So it's really gathering additional data that's going to help us better design the next version of this heat shield.
Talk about your personal experience. I mean, you worked on shuttle for a while, and then you're doing this. How different is it to work on a brand new program that, we've been talking about Orion for a while, for a number of years. It was, part of Constellation. Now it's part of, now we call it the multi-purpose crew module. Is it awesome to finally see this stuff becoming real, that, real pieces of hardware are being built and down there at the Kennedy Space Center, and we're, almost a year out, or less than a year out from actually flying now?
It is. It's completely different, actually, because I was not around when we did the DVT&E of the space shuttle.
The actual designing.
So I came on board for, I think it was STS-26 was my first shuttle mission. So coming into Orion as we're designing the vehicle, and then seeing it go from paper to actual development units on into building the actual flight structure.
Yeah.
It's a very rewarding activity to be able to participate in.
That was kind of my reaction too when we've seen so many mock-ups here at JSC and some of the other places, and the first time I saw a piece of real hardware of Orion back when I was working on that, that particular program, it was like, God, this is real. I mean, this is real stuff that's actually going to fly in space. You kind of get that sort of geeky cool vibe back, whenever you see it for the first time.
In Orion, it has so many, it's so compact, whereas the shuttle was as large as it was.
Massive.
You've got all these mechanisms and structural pieces, but it's very large, whereas Orion is very compact, so you've got numerous mechanisms and subsystems in a very small area, even though it's a large vehicle.
Yeah.
crew module.
So does it seem real now that the flight's about a year about?
It does seem real. It does seem real to see it coming together out in the ONC, and each piece, each thruster that gets installed, each parachute that gets installed, and now with the heat shield coming in, that was it. That's a major milestone for us to have the heat shield delivered to the ONC and get that ready to be attached to our crew module primary structure.
Well, last question. What's next now that the heat shield's down there at the Kennedy Space Center? Now that it's going to be unloaded this morning, what's the next step?
So the next step is heat shield will come in. They'll start installing some of the additional instrumentation that we need. From an Orion perspective itself, we'll be doing some static loads testing on our service module. We'll continue to install our parachutes, continue to install all the components that we've got on the vehicle.
Okay, Rose Flores, thank you very much for joining us. We look forward. It's going to be a cool flight next year. I don't know. We take a look at this EFT-1. It's going to be pretty dramatic. If you want to follow along with the development of Orion or take a look at what's ahead for EFT-1, just log on to nasa.gov/Orion. You can see all the different pictures and follow along there. So thanks again.
Thanks, Josh.